Vanishing gradient problem and solutions. Vanishing gradient problem. Description. The vanishing gradient problem occurs during backpropagation in deep neural networks when gradients become very small as they propagate backward through layers, leading to slow or ineffective learning. Causes. Activation functions. Description. Sigmoid and tanh activation functions can saturate, causing gradients to approach zero for extreme inputs. Depth of network. Description. Deep networks with many layers amplify gradient attenuation as gradients are multiplied across layers. Initialization. Description. Poor weight initialization can lead to gradients becoming too small during training. Solutions. Weight initialization. Description. Initialize weights using techniques such as Xavier or He initialization to ensure gradients are neither too large nor too small at the start of training. Activation functions. Description. Replace sigmoid and tanh activations with ReLU rectified linear unit or its variants leaky ReLU. Parametric ReLU to mitigate gradient saturation issues. Batch normalization. Description. Normalize activations in each layer to stabilize learning by reducing internal covariate shift, aiding in gradient flow through the network. Gradient clipping. Description. Clip gradients during backpropagation to limit their magnitude, preventing them from becoming too small or too large. Skip connections. Residual connections. Description. Introduce skip connections or residual connections in deep networks to facilitate gradient flow and alleviate vanishing gradient issues. Long short-term memory LSTM networks. Description. Use LSTM or other gated recurrent units GRUs in recurrent neural networks RNNs to mitigate vanishing gradient problems inherent in sequential data learning.